Hello viewers. In the last video, we understood what is electric current and its applications regarding electricity chapter. In this class, we'll try to understand what is the electric power and electrical energy. This is the last concept of that chapter, electricity. Okay, in the last, I think videos up to 6 we done based on that electricity chapter. This is the last video. How electric power and electric energy are related. See, what is that electrical energy first? So, you know, children, what is energy? Energy is nothing but what you have capacity. Okay, how much capacity you have to do work. That is nothing but what energy, right? Energy is nothing but simply capacity of the person will have to do work, like that only. Here, electrical energy means electricity. That means what you pass in the current. How much that will have energy means how much that will do work. Based on that, it can tell how the energy. So, is the energy that is associated with the charged particle because of their position. Okay, electrical energy, how it will associated with the charged particle because of their position. We can call it as a electrical energy. Electrical power. How are we going to divide electrical power means is the rate at which electrical energy is used in a circuit. Okay, how much electrical energy is used in a time, that is nothing but electrical power. Okay, the rate means always we can rate 1 by T. What using electrical energy? So E by T is nothing but the power we can take, or else we can write work done by time taken. What is doing work here? Whatever you connected, no, like bulbs. Okay, to glow the bulb work need to done, and to run any missions you need to do the work. So work done in a given time, that is the power. Okay, what is the power of you? How much work you are doing in a short interval of time. Suppose you will complete, okay, you will complete 10 joules of some work done. Okay, 10 joules of work you done. Okay, that is what in a time, in a shorter time, let us take in 2 seconds only you complete a 10 joules of work. Then you will said to be having more power, right children? Like that, power means how much of energy consumed in an electrical circuit, or rate at which electrical energy is used, consumed, or we can write used in a circuit. Suppose we will connect one bulb. Okay, but we'll connect, let us imagine we connected one 40 watts bulb in a circuit. How much it can use the current? Okay, or electrical energy coming out from this bulb, 40 watt bulb, in a given time. That is nothing but power of the bulb. Okay, 220 volt. They will write on the circuit or the given circuits what is the rating of that. Next, the rate at which electrical work is done. Electrical work is done. That is nothing but electrical power. So power is given by current into the voltage. Current, how much current and how much voltage. Suppose this is a circuit, imagine how much current is flowing through the circuit, and what is a voltage means what is a voltage, total 10 volt, 20 volts we are providing, no? That is what voltage. So current into voltage times the power of this bulb will depend. Okay, power will depend on how much current we are passing, how much voltage across the bulb. Okay, that is given by P into I. P is equals to V into I. SI unit of power is watt. Okay, why watt will come? Okay, this scientist watt is invented this, no? So that is why they given the name same watt. Okay, watt we can also write it as what? Watt is nothing but see current, ampere, voltage, volt. So if current is 1, voltage is 1, if it is a 1 ampere, okay, voltage is 1 volt, that time you will get watt is a 1 watt. So 1 watt meaning you get 1 ampere and 1 volt. Okay, you need voltage and you need ampere. I hope this is clear, children. What is electrical power? See, what is energy? First of all, capacity to do work. Here, what is doing work? Capacity, like electrical energy consumed in a given time. That is nothing but power of that electrical appliances. So, power ratings they will give on the some electrical appliances. More than that power rating, we provide the current. That time it will go into fuse. That we'll discuss later. The rate at which electrical work is done, it is nothing but electrical power. So, power is given by in a given circuit. Power is given by how much of current flowing in a circuit and how much of voltage we provided. So current into voltage. SI unit of the power is watt. Meaning of watt is 1 ampere and 1 volt. That is meaning of 1 watt means. I hope this is clear, children, regarding the power. Yes. This one. Next, see electrical power and electrical energy. That if you combine the electrical power equation with the above equation, which is equals to IR, what you will get electrical power equation, children? Power is equals to current into voltage. Okay, this is what equation you got. This equation you will going to combine with. Okay, we're going to combine this equation with the voltage, Ohm's law, V is equals to IR. So these two equations now we're going to combine and see what you'll get. So let us take P equals to I into V, right? In place of in place of V. Okay, in place of V, we're going to replace this one. So what we'll get in place of V, you replace I into R, you will get, right? Here one I is there. In place of V, I removed and wrote IR. So I into I, how much? I square R you will get. Okay, this, like this you need to replace for V. Suppose you want to replace for I, imagine if you need to replace for I, what you can write? In place of V, I can write I by V by R I can write into V is there. So V into E, V square by R. So both the ways we going to represent the power. In terms of current, if they give current, in terms of voltage, if they given voltage, right children? This is the power formulas. Remember, power is given by I into V also. Is also given by I square R, is also given by V square by R. This is regarding the power formulas, electric power. And electric components measures, okay, electrical companies, like how much current you used in your home, that is given by energy consumed in kilowatt hours. Energy consumed in kilowatt hour. Okay, that energy consumed in our home, that is kilowatt hours, is given by. See how you can represent kilowatt hour. See, 1 kilowatt hour, right? So kilo means what? 10 power of 3. So 1000. 1 kilo means 1000 meters. 1 W. W means watt. Watt, right children? So you write watt only. Next you write hour. Okay, 1 hour equals to how much children? No, 1 hour is equals to 60 minutes into 60 seconds. Right? 60 into 60, what you will get if you multiply? It will be 3600 seconds. Okay, so this is 1000 into 36. If you multiply, what will come? 36 into your 2 zeros and your 3 zeros. So into 10 to the power of 5 seconds. 36 into 10 power of 5. Or else we can represent in a correct way. This point, 1 point you put from here, it will get 1 point will go to right here. So 3.6 into 10 power of 3.6 10 power of 6 joule. This is the 1 unit of current, what you are telling. In your home, electric bill will come. No, the electric bill, they will tell 2 units you consume, 4 units will come. That unit meaning is the 1 kilowatt hour. This many joules will 1 unit contain. 1 unit of electrical power contains how many joules? 3.6 into 10 power of 6 joules of energy. I hope this is clear, children. This is known as kilowatt hour used for commercial purposes. Okay, let us take one small problem on this chapter to understand better. Let us take problem here. An electrical bulb consumes, one electrical bulb is there. Okay, the electrical bulb consumes, what is the voltage? Consumes to a 220 voltage. Okay, this is voltage given. Generator, the current is, current given as 0.50 amperes of current. What is the power in the bulb? Now you need to calculate the power. See children, which formula we will use among this and this. Okay, see V, I into V is given, I and V. So we can choose for first formula only. So I into V is the power. So what is the I given as 0.50 means we can write. And voltage, how much is given? 220 volts. Okay, so multiply this 0, this point will cancel, 22 into 5 is 0. So 5 2s are 10, 1 remainder, and again 5 2s are 10, 1 11. So this is a 110 watt. Okay, like this we're going to calculate the power, children. I hope this is clear how you are going to calculate the electrical power. By given current and voltage is given, you are going to calculate the power like this. So here one more problem is, I just solve this problem. You see, an electrical refrigerator rated 4000. Okay, 400. I'll write here. Electrical refrigerator rated 1400 watt. That means if a watt symbol, that means that it is a power. Okay, power given as this much. Operates 8 hours per day. What is the time duration? They given 8 hours per day. It is operating 8 hours per day. Like that, what is the cost of energy operated? You need to find the cost of energy operated for 30 days. Okay, number of days are 30 days. Of rupees, how much cost? It is for each 1 unit rupees cost by 3 per kilowatt hour. 3 rupees per kilo. 1 kilowatt hour it is 3 rupees. Like the you need to calculate the power of the refrigerator. It will work for 1 month. Per day it is working how many hours? 8 hours. So let us calculate now. So how to calculate the power now? Let us see. See, to all you're going to multiply it, power into time. So power is 1400. Okay, not 1400 watts power into how many days? Okay, how many hours? 8 hours. How many days it is working? 8 hours it is working per 30 days. Clear, children? So if you multiply all this, you will get the answer. So multiply 8 4s and 3s. So if you multiply this, you will get 96 000 you will get. Okay, multiplying this you will get answer. So you get, this is the, in terms of kilowatt hour we need to represent. No? So you can write 96 kilowatt hour. This is 96 because this is the watts given, this is in hours and this is in number of days. So it is 96, this 3 zeros we are moving on 50 kilo. So 96 kilowatt hour is the power. Clear, children, how to calculate the power? Now this cost we need to calculate. To find the cost for 1 kilowatt hour, okay, it is ₹3 for 1 kilowatt hour. Okay, I think. Okay, for that it is 3 means for number 96 kilowatt hour. It is ₹3 for 1 kilowatt hour. Okay, then how many rupees for 96? Just multiply 96 into 3 into. So 96 3 so how much it is? 288. Okay, that means we are using rupees. 288, it will come only for refrigerator. If refrigerator works 8 hours daily for 30 days, okay, 8 hours daily for 30 days refrigerator will work, it will consume power of this 400 watt. It will cost us how much rupees we need to pay? 288 rupees we need to pay. Like that, electrical bill we will give, they will calculate based on this law only. Okay, now you will calculating here for refrigerator, like that for all they will to calculate, and computer generated printout they will give to you. Clear, children? This is what the power and electrical power, electrical energy and electrical power. Okay, children, thanks for watching. Thank you for supporting. Please subscribe if you like this channel. Okay, and share to your friends who are interested for CBSE 10th board and who are need to prepare for NEET exams and all. Okay, thanks for watching, children. Please share for your friends. Yeah, see the last concept here, the fuses and the breakers. Okay, what are the fuses and what are the circuit breakers? When these fuses and circuit breakers we going to use, we want to safeguard our electrical appliances. Suppose our home will be, whatever our home, all electrical appliances are there, they will be work up to 220 volts like that. Okay, based on this, more than current will come. Imagine what happens, this is going to break, it going to melt and fuse. That is why we're going to put in front of this one fuse wire. Okay, the fuse, it is worked on the principle of heating effect of electric current. We class this. The fuse wire will going to use. So what happen inside the one box, the fuse wire will be connecting the positive and negative terminal. That means outside current will first pass through this fuse wire, again only it will pass to the inside home. So what happen, if high current will come, the fuse wire made up of nickel, that will going to melt off. Okay, when that going to melt, it becomes an open circuit. Now it is a closed circuit, the current is going inside. When a high current will come, the fuse wire going to break out. So what will create? It will create a open end, so that electrical appliances there in your home, they must be safe because no current is flowing. Okay, every time when the fuse wire will going to melt, we need to replace with the new fuse wire again. Okay, and then only electrical appliances in your home will work. That means again we need to call electrician to replace this fuse wire. It will take 1 or 2 days time, right, to repair and all, but it is cost also high. To reduce that, nowadays what they will use, circuit breakers. That is example is MCBs, miniature circuit breakers. What they will work, they will be work on not on heating, they will be work method of bimetallic strip. Okay, what we call as a bimetallic strip, which is connected in the normal temperature like this. If the temperature is high, it will come, no, the metal going to expand. You know, actually, metals goes on expanding when they're going to heat like that, they're going to expand. Now, it like this connection will be there. They're going to break the connection. They create an open circuit. Okay, initially in the normal temperature, they will be connecting, current is passing. When high temperature will come, just they're going to bend. Okay, then creates here to here, the gap is there, right? You can observe the gap here. That means current is not flowing inside. So when current is comes low temperature, again it will come to normal state. Again automatically current will go. Or else we need to trim. I think you're building some. You can to take the fuse on. Okay, like that it will MCBs will going to work. Automatic on and off switches. No, like that MCBs they going to use. MCBs means they made a work on the principle of bimetallic stick, two metals, one is copper, iron. So what will happen when high temperature will come, it will going to bend one above the other like this principle. So whatever fuse and miniature circuit breakers, why they going to use to protect the household appliances if high currents are coming or any dangerous currents are coming, they want to prevent using the fuse. Like how the gatemans will work for our house, right? Like that, the fuse will be worked like appliances to safeguard. See, when electrical wire carries more than the safer level of the current, the circuit is said to be overloaded. When the circuit is said to be overloaded, what will happen? A short circuit can happen. Okay, that is going to melt. The two wires will be attached. Short circuit will happen. You will heard my news and because of short circuit. This is the damages we'll see. So to avoid all the damages, to avoid this short circuit, we're going to use the fuse wires. What happens if a wires installation wires down? Okay, why you know wires inside the metal will be there and outside layer of the wires we're going to put a plastic. Okay, outside is plastic coating. If a very high current will come because of high temperature, this wire going to melt and the two wires will going to attach to electrical wires. That is positive and negative attach. What happen? Here to here only it becomes short circuit and current will go back instead of going into electrical appliances, and at that sometimes appliances also will going to break. Okay, two wires touch and creating an alternating pathway for the current. That is what we call short circuit. And fuse melt to prevent the circuit overload. Okay, fuse wire is going to melt. I told you it's going to melt and here create an open path, open circuit. That means current is not from passing from here to here, so that appliances in your home will be safe. So fuse an electrical device that contains a metal strip that melts when current the circuit begins to break. Okay, this is about the electrical breakers and the fuse. Okay, I think in electricity chapter what we covered so far, all the topics is clear to you, right? Okay, if you have any doubts regarding any topics, you just comment or you can ask. Okay, if you have my number, this is my number 90194371. Okay, you can just message this to WhatsApp message if you have any doubt regarding the electricity chapter, or if you want any doubts, you just email also. This is my email address. gmail.com. Okay, children, you can do like this. Okay, thanks for viewing and try to share your friends. Let them read this. Okay, make them helpful. Thank you all, children. Have a nice day.